So when it says simplify, you're just going to do, if you're adding and subtracting, combine like terms. If you're multiplying, you're going to FOIL and then simplify your I-squareds. So for this first one, I always deal with the real portion first because that's the standard form. So when I look at this, I'm going to deal with that -6 first. -6, and then you see a common term of +6. Well, -6 plus 6 is just 0. And then I have -6i minus 6i. That's -12i. The simplest form of this would then just be -12i, and you are done. So multiplication is very much like when you had variables as well. You're just going to FOIL here at first. You're going to say 2 times -8 is -16. 2 times +2i is +4i. -8i and -8, +64i. And then -8 and +2i is -16i squared. So normally we would just combine our like terms. But before we do that, when we have i's involved, we need to think about the fact that this right here is the same thing as -16 times -1. So that's the same thing as +16. And once you do that, you want to combine your real portions and your imaginary portions. And so if I look at the real, actually, once again, negative and positive, that actually turns to a 0 as well, like it did above. And then I have 4i and 64i, and that is 68i. Again, your most simplest way to write this would just be 68i. If it was anything other than 0, you would have left it as some real number plus the imaginary number. Absolute value is the distance away from the origin. You have a real movement and an imaginary movement. The real movement is the first number. The imaginary movement is the coefficient of the I. And so the formula for this, to find the absolute value of an imaginary number, you're going to say that is the square root of the real part squared plus the imaginary part squared. So for this one, my real portion is 7. I'm going to square that. Plus my imaginary part is -1, and so I'm going to square that. And so at this point, I'm just simplifying. I have 49 plus 1. That is the square root of 50. As always, you want to simplify this if you can. Remember that if it has a pair, it's going to come out of that root. If it is single, it is going to stay in. So my final answer here is 5 square root of 2. All right, when you do not have just an x, when you only have an x squared and numbers, it's easiest to solve by taking the square root. And so I'm just going to get that variable squared all by itself, and then I'm going to take the square root of both sides. So in this case, I am going to add 6 to both sides. I will get 6n squared equals 438. Then I'm going to divide both sides by that 6. And I am going to get n squared equals, and then take that divided by 6. I'm going to get 73 there. My final step here is just to take the square root of both sides. Square root of the left, square root of the right. Remember, when you have the square root with a variable involved, it is the positive and negative root of that number. If 73 reduced with a factor tree, I would reduce it. It does not. So there's nothing that can come out of that. So that actually is my answer. If it was a negative number here, I would pull the I on the outside. If it was factorable, where I could have some numbers that pair up and come out, I would simplify the root, okay? So always at this point, double check and see, is there a negative under there that I need to pull out with an I, or can I simplify that root at all before I'm finished? It's like reducing a fraction. Make sure you can't write it more simply. All right, when you're completing the square, you do want to move your numbers out of the way if they're not already out of the way. So for example, this 6, I'm going to move over first. And then I'm going to say x squared plus 2x is over here, and I have 6 over there. I'm going to use that middle number, that b, to determine what happens here. So 2 divided by 2 gives me a 1. That actually tells me how this is going to end up being factored. That's going to end up being x plus 1 squared over here. I'm going to square that and get the number that I add to both sides. So on that right-hand side, I'm going to write a 7. The left-hand side will factor according to what it was cut in half. The right side, you're going to add what was cut in half squared, okay? Because you have to add it to both sides. You have to add that square to both sides. At this point, I'm going to solve it just like I do when I'm taking the square root. I square root both sides here. Square root of the left, square root of the right. On the left-hand side, it just cancels out that square, so I just have x plus 1. On the right-hand side, remember, when you're talking about square roots, it's positive and negative root. And could I simplify that? I would, okay? In this case, 7 can't be simplified. I'm not quite done because I do not have x by itself yet. So I need to subtract that 1 over. Typically, the rational number goes in front and the irrational or the root goes second. So my answer here would just be negative 1 plus or minus the square root of 7. And you can leave it just like that. 24, same deal. I want to move that 16 over first, so I'm going to subtract it over. I have k squared plus 4k equals negative 19. I'm going to do the same thing with that middle term. I'm going to take that 4 and cut it in half. That will give me a 2. That actually tells me how this left side will factor. It's going to factor to k, and that's a positive 2. In order to find out what I need to really add to both sides, I square that, which gives me a 4, which tells me that my left side here is going to factor to the k plus 2, like I said, but the right side here is going to be negative 15. At this point, I'm going to take the square root of both sides. All right, on the left-hand side, again, you're just canceling out that square. You just get that k plus 2. On the right-hand side, you get the positive and negative root of negative 15. I'm going to see if I can simplify that. The 15 only has 3 and 5. Actually, nothing pairs up when you factor 15. But the negative can come out with what? What can I take that negative out with? An I. So positive and negative I squared of 15. And of course, to solve for k, what do I need to do? K is not by itself. What do I have to do? Subtract 2. And I will put that piece in front. So negative 2 plus or minus the square root of I squared of 15, rather, put the I in front. All right, before you start quadratic formula, you need to have the quadratic formula memorized, all right? So the annoying song is online from last night's homework, but x is always going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So make sure you know that formula. In order to use the quadratic formula, you must have it equal to 0. So remember, it has to be equal to 0. This first one is already equal to 0. We're ready to go with our quadratic formula. Make sure you pay attention that your a, b, and c are only numbers. I've had people try to put the variable into the formula. You're solving for the variable. You're only using the coefficients and the constants here. So my a is 2, my b is 7, my c is negative 22. All right, so it's going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And at this point, you're literally just doing order of operations, okay? So when we finish this, -7 plus or minus, what is 7 squared? Thank you, 49. Then we have 4 times 2 times 22, 176. 176. Yes. Oh, that has a perfect root. All over 4. When it has a perfect root, like 225 does, you are going to finish this problem out and you should get 2 rational numbers. If it has an irrational root, meaning it doesn't have a perfect root, square root of 5, then your answer will just be as simplified as you can get it, and you'll still have a radical in your answer. So for this one, I can keep going. 225 is 15 when I take the root. So -7 plus 15 over 4 and -7 minus 15 over 4. All right, I want to finish that out. So 8 over 4 gives me a 2. -7 minus 15 is going to be -22 over 4. I can reduce it to -11 over 2. So those are my 2 answers for this one. I can keep going and I can get 2 rational numbers there. So remember, it has to be equal to 0. This one is not. So before I ever start my quadratic formula, I have to add that 7 over. And then my A, B, and C will be determined from when it is equal to 0. So this is going to be 3x squared minus 2x plus 3 equals 0. Now I'm ready to do my quadratic formula. So do not do the quadratic formula until you have it equal to 0, or you will have the wrong numbers as your A, B, and C. Once I've done this, I'm going to go ahead and do it. -b, well, since my b is already negative, that's going to just be 2 plus or minus the square root of b squared minus 4 times A times C, all over 2 times A. Inside the radical, I'm going to simplify that. -2 squared is 4. I have 4 times 3 times 3, and I'm subtracting it. So what am I going to get there? Minus what? 36. Yeah, and it's going to be a -32 once I simplify it. So I have 2 plus or minus the square root of -32 all over 6. All right, so the negative piece. What's going to come out with the negative piece? An I is going to come out. For the 32, I need to do my factor tree. If you see a perfect root within your factor tree, you can go ahead and do that, and that's going to come out. Or you can keep doing 2 and 8, 2 and 4, 2 and 2, and you're going to see that 2 2s are going to come out, right? So you can stop there if you see a perfect root. So it's going to be 4 comes out of the root, 2 stays in the root, and it's all over 6. Remember, you can either split it up, 2 over 6, 4i squared and 2 over 6, and reduce them individually. Or you can see what comes out of all 3, the 2 and the 4 and the 6, and reduce them. So what comes out of 2, 4, and 6? 2. So I'm going to divide each one of those by 2. You'll notice I am not reducing inside the radical. I cannot reduce inside the radical because everything I'm reducing is outside of a radical. So I'm going to reduce this by 2. That will become 1. I'm going to reduce that by 2. That will become 2. And I'm going to reduce that by 2. That will become 3. And so my answer is going to be 1 plus or minus 2i square root of 2 all over 3. That is my answer there.